Hello, welcome to our project, Everyday Functions Key Activity. Our team is conformed by Rubén Alejandro García Martínez, Eugenio Lorenzo Vega Guevara, and me, Gerardo Alexis Reséndez Fragoso. Now we're going to proceed to explain more about our project. Well, first, the introduction. The objective of this project is to found functions in real-life situations by rationalizing and using our critical thinking in order to evaluate functions to each real-life situation. The following project will demonstrate how math equations can be used in any area of our daily lives by rationalizing the functions of each situation that are presented in different searched sites.
In source 1, emissions of CO2, our given function was the table of values. In value x was 1 year change, and in value y was CO2 emissions from 0 to 40 tons. The domain was from Indonesia to China, and the range was from 503 million to 10 trillion. In source 2 was consumption of carbon. Our given function was an equation. The domain were the years from 2008 to 2017. The range was 250 tons to infinite plus. The x was the annual consumption and the y was the year. In source 3 was the consumption of water. Our given function was the graph. The x value was the years and the y graph was the cubic meters per year. The domain were the years from 1901 to 2009 and the range was the cubic meters of water from 0 million to 5 million.
Well, source number 4 is the given function is verbal. The domain are the years 1940 to 2018, and the range is the circulation of newspapers. The estimated total US daily newspaper circulation in 2018 was 28.6, which is X million for weekday, and 30.8, which is Y million for Sunday. Then it down 8% and 9% respectively from the previous year. So how much was the circulation in 2017? Well, the answer for X is 30,948,419, and the answer for Y was 33,971,695. Source number 5, the given function is a graph. X represents years and Y represents gas reserves. The domain is 1980 to 2016, and the range is 2.5 G to infinite. So the function tells us that the x variable of year million cubic feet is multiplied by 0.1389 and then is subtracted by 272.5. The year x determines the amount of natural gas in the world, so it depends on how many natural gas was discovered in that year. It is a linear function due to the graph. And maximum is 7 gas reserves, the minimum 2.5 gas reserves. It increases every of the 3 y values. Did not decrease, the variables are continuous.
Now we're going to proceed with the results and discussion. First, where did we find our functions in the newspaper? Well, we basically found the functions really fast. All the newspapers had graphs, so we used them in this cover, and also use them to help us find the functions in the verbal and the symbolic functions, but especially in the ones where they talk about the use of natural resources. We guess that it's actually easier to graph because the x is the function that are the years and the y are the functions of the resources. Did the newspapers present the function in the best format? In our point of view, the newspapers provided enough information for the team to develop functions, even though that a newspaper had to be precise and clear. The search newspapers included an extensive warehouse of information for us to use in this project. Our results were as expected. We found a required function for each newspaper search.
Well, in conclusion, we learned that it is important to understand and analyze and use mathematical formulas to find the variables and functions for a given real-life problem, and we understand that graphs are really important in the fields of economics, business, statistics, etc. So this can help us to develop ourselves in these fields and help us in the near future. The most important thing we learned throughout this project are the basic terminologies of mathematical modeling. For example, a periodic graph, the maximum and minimum, the range, logarithms, points of discontinuity, etc., and how are they applied in real-life graphs, and how can we apply them throughout our lives.